Hey people, welcome back. And in this session, we are going to learn about how to perform the one sample Poisson rate test. So this test we perform when we are looking for the defect rate. Defect rate means you have a production, suppose, and you have done the production of, let's say, 1000 pieces. Out of that, you have a rejection. Number of defect you have observed is around, let's say, 23. So the defect rate of your data is 23 by 1000, which is around 0.23. Now, suppose you have a target defect rate that the rejection should not be greater than 0.05, which means 5% in simple word will say. And you wanted to compare when you have the 1000 sample you have taken, 23 rejection you found, defect rate is 0.023. Either you are less than statistically with the number 0.05 or not, which means if it is less than 0.05, you are meeting the target. If it is equal or more than 0.05, then you are not meeting the target because defect rate what you have is lower is better. LB, lower is better. In such condition, we perform this test. So if I use the mini tab, I put just simply go to the stat, basic statistics, and here I select the one sample Poisson rate test. So data I have already summarized, where sample size I am taking 1000, total occurrences was 23, and the target is 5%, which is 0.05. Click on OK, and here we see the result. So what does this indicate? If you read the hypothesis, hypothesis says 23 out of 1000 is 0.023 defect rate, which statistically is ranging as per this data is from 0.014 to 0.03. And your target is outside 0.023 confidence interval, which is 0.05. So mathematically, obviously, this value and this value is not same. And the same, they are statistically also not same. 0.03 is ranging from 0.0145 to 0.0345, which is much lesser than 0.05. So they are statistically different. Because the defect is always lower is better. So in this case, I'm meeting the target. And my alternate hypothesis says that observed value 0.023 is statistically different from the 0.05, which is on the lower side of the specification. Because defect is lower is better, so I will conclude that I am good here having the lower defect rate than the target, which is statistically proven by the p-value. That's how we interpret, read, and take our practical decision on the one sample Poisson rate test. Thank you, people. I'll see you in the next session.